So good morning, and thank you for joining our Girls Exploring Engineering Day. I am Amy Good, the Program Manager for the Community Education Center for Elk-Cameron counties, and I'd like to thank Lauren Zickafus, who is a WIM member, for helping me organize this program, and for the Western PA Women in Manufacturing for sponsoring our event today. Engineers are changing the world all the time. And as we recognize National Engineering Week and Imagine Tomorrow, we see engineers in the heart of solutions to combat climate change, to secure cyberspace, and to develop vaccines, and much more to make the world a better place for all of us. In a predominantly male-dominated field, with only 13% of women working in the engineering industry, I'm happy to report that you will meet some of our area's women engineers today who will share their journey, hoping to inspire you to dream big and become a creative driver for our future. Students heading into this career field struggle with the decision of what type of engineering they want to pursue. Our agenda today will showcase a variety of engineers, and our bingo game will give you an opportunity to learn about many more. We will start with an introduction to WIM and then have a Q&A session with our guest engineer panel. After a quick break, we will learn about a few education programs related to engineering, and then we will finish up helping you find your fit in engineering. So we're going to go ahead and start with a few bingos to get us started for the day before we move in. So our first bingo for today is chemical engineering. Chemical engineers develop and design processes to create and manufacture chemicals. And here's a little tip that the field of chemical engineering is very secure, with the possibility of a very lucrative future awaiting those who are able to establish a solid career. Next up, we have mechanical engineering, who design, produce, and operate machinery. And here's a tip: if you are naturally curious about how things work, do you take things apart and put them back together? Then this is a natural trait of a mechanical engineer. Our next one is electrical engineering. They study and develop technologies to apply energy in practical new ways. They design components for electronic equipment, communication systems, power grids, automobiles, and more. A little tip is that electrical engineers typically work together with other engineers and other professionals. So with this, they should work comfortably and efficiently with a team. So if you are a good team player, electrical engineering might be a choice for you. Then we have biomedical engineering. They design skills to biological and medical sciences to advance healthcare, treatment, and technology. And civil engineer. They design, build, supervise, operate, and maintain construction projects and systems such as roads, buildings, airports, dams, and much more. A little tip is, as the population grows and the need to expand structures increases, more civil engineers are needed. Aging infrastructure is among the main reasons for this growth. Okay, so that's going to end round 1 of our bingo game. All right. So at this time, we're going to move on, and I want to introduce Melissa Monarco. She's the co-chair of WIM Western PA, president of Metal Solutions, and she's going to share with us what women in manufacturing is. So welcome, Melissa.
Good morning. Thank you for having me. Again, my name is Melissa Monarco. I'm president of Metal Solutions. We are a CNC machine and fabrication job shop located just north of Pittsburgh. If you're not familiar with the term job shop, basically what we do is take the designs of engineers, much like the ones who are participating on this call today, and make them come to life. So we take aluminum, steel, plastic, stainless, and other types of material and machine or fabricate it into the products that are used in various industries today. So in addition to managing Metal Solutions, I also serve as the vice chair of the Women in Manufacturing Western PA chapter. I joined WIM in 2016 and helped to form our Western PA chapter. For me personally, WIM has been an amazing organization that has given me the opportunity to network, learn, grow, and feel confident in the traditionally male-dominated field of manufacturing. So what exactly is Women in Manufacturing? WIM is the only national trade association dedicated to supporting women who have chosen a career in the manufacturing industry. While WIM is a national organization, it has a network of state and regional chapters so that members can connect on a local level. There are currently 26 active chapters across the US, with new ones developing. Here in Pennsylvania, there are 3 chapters, and we are part of the Western PA chapter, which covers the western part of the state from Erie to Washington, PA. So what's cool about the WIM organization is that it not only supports professionals like myself, but it also helps support students like you who are looking to pursue a career in manufacturing. As a student member, you would have access to a monthly newsletter, which gives industry insights into manufacturing, a professional profile in the WIM directory, so it's never too early to start marketing yourself, the ability to seek job opportunities or internships on WIM's job board, free monthly educational webinars for personal and professional growth, the ability to participate in chapter programs such as the one you're participating in today. Currently, we are only holding virtual events, but in a pre-COVID and hopefully post-COVID world, we will resume plant tours to see manufacturing in action. Overall, WIM is a great way for students like yourself to start early in building a successful career in the manufacturing industry. And it's only $35 a year for a student membership. So I would encourage you to consider joining, and I am sure a link to the WIM website will be shared after our call. Thank you for your time and attention, and I wish you all success in your studies and your careers.
Thank you. Thank you, Melissa. What a great group and a great opportunity for those interested in engineering. Okay, so at this time, I'm going to pass it on over to our keynote speaker, Sandy Lowry. She is from Advantage Sales and Supplies, and she is a chemical engineer. So welcome, Sandy.
Good morning, everybody. Can you hear me? I just want to say, first of all, thank you very much for allowing me to participate in this. I'm really excited, and I was really surprised and amazed at the level of participation that we were able to develop and pull into this event, even being virtual. I couldn't believe the diversity in all the school districts that I saw listed there during the chat. So I cannot speak from the hip for 15 minutes, so I did a PowerPoint because I need to stay on track. So I'm going to share my screen and go through some slides with you. So let me do that first, make sure it works well. Okay, everybody seeing this? Let me get it started. Okay. So what I'd like to do today is go through just an overview of my career path. I'd like to share essentially who I am, just to give you a little bit of bio. It's why I chose engineering, the path that I actually got to follow, and then turn that around and bring it back to all of you and why choosing engineering now is particularly desirable. And then some final closing advice. So many of you don't know me. I'd like to start out with, I'm a Ridgeway, Pennsylvania native. That's the Ridgeway Elker emblem there. So I see some Ridgeway folks are on the call today. I was born and raised here, graduated from the high school in 1989. So if you want to do the math, go ahead, you can see how old I am. And then left for a while and came back. And now I live and work here with my 3 kids and my husband for the last 11 years. And working here at Advantage Sales, which is also in Ridgeway, as general manager. So way back in 1989, when I was deciding what to do and go to college for, why did I choose engineering? Well, first of all, I had a mother who was a teacher who made me go to college, told me I had to, right? But deciding what to do was really difficult. And in high school, I loved math and chemistry and physics, and I had awesome teachers in high school who also were men, but they were influential and they recommended engineering to me as a possible career choice. The other thing that was pretty impressive, and I think you all should appreciate, is the return on investment. So when you go to college, it's really, really expensive. And when I was looking at, what's the average 4-year college degree now, it's about $120,000. And so if you're going to spend that much money, you want to be able to make the money back. And in 1989, chemical engineers were in the top 10 for return on investment. And so that was part of my choice. Oops, I'm going the wrong way. And 2 of my friends were going into engineering. So that was part of it. And lastly, in 1989, it was really not a field women went into. And a lot of people said no to me. No, that's not a good field. You'll never get a job. Women don't do that. And honestly, that just made me even more excited and more motivated to go into it. So I chose engineering. I went into chemical because I liked chemistry. So as part of my college choice, I went to Penn State. They had a great chemical engineering program. I was able to minor in environmental, which was very influential. And I'm a big Nittany Lion fan, so that made it pretty easy. Later in my career, though, I did get an MBA. I went back to SUNY Buffalo up in New York State. But I wanted to reiterate to everybody here that, learning really has no boundaries. It's not something that ever ends. I went to Penn State for a lot of really good reasons and later followed up with SUNY Buffalo, but every day I'm still learning. It's something that you need to be committed to. I know you girls are probably getting really excited about graduating from high school and going on to other things, but you'll find in your career paths that becoming a lifelong learning, you never stop your education. Okay, so a little bit about me. Once I graduated from college, I went to this lovely place, which is in Niagara Falls, New York. It's Oxy Chemical. It's a sea of piping and distillation columns, and it was extremely intimidating when I went there. I was what you call process engineer. At the time, there was only one other female engineer there of the 500 employees. There was another female engineer and some other women. I stayed there for a lot of years. It ultimately did shut down and I had to move on to other career paths, but it was a really big learning experience for me from the perspective of being a minority, being able to survive, learning a ton, and really developing the knack to become flexible and support the other women that were there. When that plant shut down, I went into a new industry, the glass industry. I worked for Corning Glass in State College. They made that really old style TV screens, the ones with the big heavy funnels, and was a production engineer. As part of that, it got a little better. There were a couple more engineers there, similar size, 3 other female engineers, so it wasn't such a minority. But guess what? That plant shut down because the technology changed, flat screens came into play, and this particular facility never morphed into the flat screen production. So I looked for a new job and went into a completely different industry. At that time, I moved to Buffalo, New York, back up to that area, and worked in a testing and compliance facility called Bureau Veritas. That led to a very new transition for a role for me, and I went into sales. So I was previously always in engineering, hands-on, making stuff in manufacturing, and this time I moved to sales. And that meant I was no longer in a facility tied to a process. I was actually out talking to customers, selling, testing, and services, which was very different, but still used my chemical engineering degree to understand the process that we were selling. This was a big turning point. There was a very diverse workforce there. There were a lot of women engineers, a lot of women in the sales force. You know, at this point, it's 2001, and it was a big tipping point for me when I really started to see the diversity of women in leadership roles throughout the technical industry. But for me, I started family, I had kids, I got married, I decided to move back home, back to my Ridgeway roots, and I took on a new job. So it's 2009 now. I started working at Graphtech in St. Mary's, Pennsylvania. They make those big, huge electrodes you see in the picture there for the steel industry. And what was interesting about that plant is it took a big step backwards in the diversity spectrum because they didn't have a lot of women there. So I worked in HR as the HR director, which I had absolutely no background in whatsoever, and morphed into production management and engineering. At that time, I was the only female engineer in that entire workforce. There's 150 people there. And eventually that plant also shut down. But you can see what I want you to appreciate is how with an engineering degree, you know, although the industries change and plants shut down, is very able to then become flexible and morph into various roles, whatever was required, learning and understanding and developing the skills to fulfill different roles. So I changed again in 2018. I worked for American Refining Group up in Bradford, PA. If you ever drive through there, you see the oil refinery right off of the interstates. I worked in the process safety management for about a year. Again, though, this was an enormously powerful and amazing place because the plant manager there, the woman that led this whole facility, wanted to hire more women. And she herself was not an engineer, but she appreciated that level of diversity and inclusion for women. And so I felt extremely empowered. I loved working there. There were tons of women in leadership roles across the whole facility, wearing all different hats. I hated the drive in the wintertime. I can tell you going to Bradford every day was tough. So when a job in Ridgeway came up, working here at Advantage Sales, I moved back here. And that's what I'm doing now. Again, another lifting and rigging, totally different industry for me. But the women here already fulfill half the leadership roles within sales and accounting and, me in general management and operations. And that's been enormously amazing and powerful. The level of diversity that we're able to supply, and the culture is very progressive and inclusive. So that's a little bit about me. That's my path. In a nutshell, though, when you look at it, why, for you girls, so why engineering now? Why would you even consider it? You can see there are all these paths available. So for me, I was a chemical engineer, but I worked in all those different industries: chemicals, glass, testing, electrodes, oil refining, lifting and rigging. None of those overlap. None of those have anything to do with each other. But you're able to morph just by having that foundational degree and get very good jobs with very exciting different problems to do every day in all different worlds. in addition, engineers, I don't care what type of engineer you are, you can perform many different roles through the technical world, into the business and sales. Those are just some of my job titles that I held with process and production, into a sales group, into the HR world, which has very little overlap with engineering, the process safety, and into general management. And I guess what I'd say is, it's really evident to me that the career paths are no longer so narrow where you get one degree and that's all you do for the rest of your life, or you only work at one place for the rest of your life. That's just no longer valid. And now more than ever, we've got to be able to adapt to as the industries change, as the world is changing. And I feel very confident that with an engineering degree, that's possible. There's my high five. Okay. Number 3. So the other really cool thing and exciting thing about engineering is every day brings new problems to solve. And these can be all different things related to the process and making things more efficient, making things more profitable, making brand new products, improving quality. There's always something new to resolve every single day. It's never boring. I honestly can say that every single day I use my engineering concepts. Maybe it's not all the technical stuff every single time, but you always go back to those core skills that you're probably already very strong in, and that's math, chemistry, physics, the common sense stuff that helps you to resolve problems every day. But probably one of the more important things is job security. So job security, as I was literally listening to the news this morning. They were talking about how the Biden administration is supporting manufacturing more than ever because they're very concerned about our inability to supply really critical things here in the United States, mostly as a result of the pandemic. But their priority is to make Made in the USA where it was before. And there's an enormous shortages of engineers in America. And as I heard Amy say, 13% of engineers are women. Well, guess what? 57% of the women in America hold the bachelor's degrees. So why aren't there more engineers? And that's what we're trying to resolve today. And this is why, pursuing engineering now more than ever with the federal governmental support and the fact that there's already a shortage is even more desirable. And as I said, there's a return on investment. Engineers make very good money. These are good jobs that pay very well. When you pursue a college degree that's going to cost you $120,000, you want that job security. And you've got to remember that you have to look at what's the return on investment. And engineering degrees are extremely desirable. They're obviously very marketable, and you can be sure that you're going to make a good wage when you get out. But to pull it more together back to the girl side, I just want to say, you girls, you're in this Generation Z, I'm hearing. And as I read a little more about it, Gen Z women, they are more empowered than we ever were, fearless, independent, inclusive, demanding the diversity and requiring that our future is better. It's resulted in this powerful group of women that are now coming out and entering college and the workplace. And they're supported more than ever from their parents and their friends, each other, schools like we're doing right now. And you girls are going to have a part, with more options than we never had back in my day. And so I'd like to share this video with you because I think it really sums up. It was something that my sister-in-law pulled together in her workforce, and she helps athletes get jobs and recognition. But I think if I can play it for you. Okay, let me go this way.
50 years ago, a woman couldn't always compete, couldn't love who she wanted, couldn't be celebrated for her dominance. Now she can.
We can't see it.
All right, let me start over, sorry. A little technical
50
difficulty.
years ago, a woman couldn't always compete, couldn't love who she wanted, couldn't be celebrated for her dominance. Now she can. They said a woman couldn't keep up with the boys, or win as many games, or attract as many viewers. Then she did. The average woman still doesn't get equal pay for equal work, doesn't enjoy the same recognition as her male peers, doesn't command the same attention. She knows exactly what equality is, and she wants to have it. She will.
Okay, pretty powerful stuff there. But, oh, sorry, okay, there. So I guess in closing, ladies, what I'd like to tell you is be fearless. You know, we've had a lot of years to build on this, and you girls are walking into a new horizon like never before. And so I love what we're doing here today, supporting each other and sharing our experiences. And I wanted to throw my phone number and my email address. If you ever have any questions or need anything, I'd like to share, you know, anything else with you. So thank you so much for allowing me to participate with you all today.
Sandy, thank you so much. I just wanted to see if any of the students had some questions. Lauren is monitoring the chat. So Lauren, do we have any questions for Sandy?
So there was one on here and Sandy kind of covered it after it was mentioned, but I'll just bring it up again. So Maya Lynch asked, how often does an average engineer have to find a new job and how easy is it to find one?
So, I mean, I think what the big difference is that manufacturing, which is often where engineers work, I know many of us on this call today do, has shifted significantly. I mean, certainly for me, you can see from my career path, I had to change a lot. But it's really becoming a lot, there's a lot more longevity and a lot more consistency because there's a shift back to supporting manufacturing and maintaining and sustaining here. It really depends on what type of engineer you are, what world you're living in and working in, what industry you're working in. But more typically from what I see now is, you know, generally around 4 to 5 years, sometimes, very often people are looking themselves because they want to move into different roles and pursue different career paths. But what I see, I can tell you here in Elk County where I've worked, there's not a lot of movement. A lot of people generally stay in similar industries and stay in their original roles.
Thanks, Sandy. Another question was, what has been your favorite job?
Oh, good question. Certainly, I don't know. That's a good question, really. I guess my first job was probably my absolute favorite just because we were making specialty chemicals that no one in the world, nobody else made. We were the only ones that did it. And so there was an enormous amount of pressure every day to make sure that we were making it better and better. And so, and to know that you're the only ones was, you know, one, I guess, distinctly empowering and, but relatively cool too, but.
Thank you. And Abigail, yes, we're recording this presentation, so we'll be able to share that with you. And then Sandy, I don't know if you want to just touch on this a little more. We had another question come in. If you could tell us about one of your favorite or most memorable engineering projects you've been able to work on.
Okay, that's a great thing. And I can tell you in industry, it's it's a lot of projects. It's generally, you know, for me, it's been a lot of little projects, but early on in my career, at Occidental, I was part of a team where we did a lot of little startups. And so we would take the, you know, here's lab scale, how you make it in the laboratory, and take it to the industrial scale. And we were that transition team that ensured that it worked. And so when you take something from very small benchtop scale to something that you actually have to make in the real world and figure out what all the problems are, and you're working day and night, and believe me, it was really hard, but it's enormously gratifying when you come to the finished product and it's working. And so I did a lot of those. It's really, really difficult, and you learn everything very well. But the gratification at the end is so worth it.
And we'll take this as our last question. The students from Ridgeway would like to know if you have any special advice for chemical engineering specifically.
I guess what I would say is, for sure, learn as much as you can. Now more than ever, industries are very diverse. And so, you know, for me, I was very interested in the environmental side and the sustainability overall. And so that's why I got a minor in it. Once you have the background and the foundational information from a 4-year degree, I really believe you can do anything. And so go to school, go somewhere good, go somewhere that, you know, is renowned for engineering, and learn and take as much as you can, because it will always help you later. But be flexible, because guess what? You know what I mean? Industries are constantly changing, and so is technology. So don't feel, you know, don't be complacent, because it's not going to be the same thing forever.
All right. Well, thank you very much. We're going to move on, but thank you, Sandy, so much for your presentation. It was great advice. And thank you for sharing your contact information for the students to reach out if they have any questions. All right. We're going to do a quick bingo now before we get to our guest panel. So and I apologize, I was so excited to start the bingo, I forgot to mention that the winning card will be either, you know, straight across, down, or diagonal, just like a regular bingo. So our next bingo is petroleum engineer. They're one of the highest paid engineers and design tools and technologies to extract underground oil and gas. And a tip is that the job and employment outlook for petroleum engineers is quite good. If oil prices rise, the need for companies to hire more petroleum engineers will also increase. This is because companies will have to adopt more complex operations, and they may have to drill deeper and find other areas where oil and gas are abundant. So that's a nice little tip. The next is agricultural engineer. They design, construct, and improve farming equipment and machinery. So if you like the outdoors, agricultural is a nice selection for you. A sound engineer. So they assist in recording, manipulating, and analyzing sound using equalization and electronic effects, mixing, reproduction, and reinforcement of sound. So if you are into music, a sound engineer might be a fit for you. A robotics engineer focuses on automation and creating machines to assist with daily and/or complex tasks. A computer hardware engineer designs and develops computer systems and other technological components and devices. If you are into technology, computer engineering might be a fit for you. Automotive engineer specializes mechanical engineer, creates, improves mechanisms and designs for cars, motorcycles, trucks. Okay, and that's going to end round 2 of our bingo. So at this time, then we're going to move on to our guest engineer panel. We have 3 different types of engineers, and we're going to do a little Q&A round robin with them. And if we have time, then at the end, we'll take questions. So if you have questions that you want to put in the chat throughout the session, feel free to do so. Oh, Lauren, do we have a bingo?
Yes, I was trying to find a good time to jump in there. We do. So we have quite a few. It looks like we did get our first 4. We have Christy Mogul, 2 students from Westmont Hilltop, and then Danica McChesney. And then, yeah, our last 4th one, we're doing the top 4, right?
The top 4 are going to be winners. Yep.
So Danielle Sutherland.
Okay. All right. If you can write those down, that'd be great. All right. So that's great. Okay. So at this time, I'm going to introduce our panels. We have Laura Ordaz. She works with Komatsu, and she's a mechanical engineer. Elena Petrak, consulting firm, and she's an electrical engineer. And Bethany Ford from Allegheny Coatings, and she's an industrial engineer. So I think we'll just go ahead and start with Laura. If you want to tell us a little bit about yourself and your personal career pathway, you know, where you're from, what school, what you did after high school, and what you do now, like what your job title is now.
Great, awesome. Thank you so much for having me today. This is really exciting. You know, also being a minority in the classroom and at work, I'm one of maybe a handful of female engineers. This is really great to see so much participation today. So I'm really excited about that. So about me, I was born in Bethesda, Maryland. And we moved here, my family moved us here when I was a baby. And so I grew up in Oil City, Pennsylvania, in the Dempseytown area. And I've lived here ever since, other than going to school. And for school, I went to Slippery Rock University. I got my undergraduate degree in physics. I got my bachelor's of science in physics. And I went to West Virginia University and got a master's in mechanical engineering. Right out of high school, I went directly to school. I was pretty confident in what I wanted to do. And I was pretty interested in furthering, you know, my education. So I just hopped right into it. So yeah, I applied to engineering. Well, at that point, there was no engineering degree. So I started right into the physics degree. And at that point, there was, I'm not sure if it's still available, but there was a program called the 3+2 program, and you'd go for 3 years at Slippery Rock University, and you would get a bachelor's of arts degree in science, and then you would finish off at a different school set in the program, such as Youngstown University, West Virginia University. I believe Penn State was in there at one point. And you would finish 2 years there, and then you would get a engineering degree. So I started into that, and then decided that I wanted to get a full bachelor's of science, a full 4-year degree in physics, because I loved it so much. So yeah, then I went right into, I didn't take any gap year or anything between undergrad and my master's degree. I went right into it.
And what do you do now? What's your job title? What do you do?
Yeah, so I work at Komatsu Mining Corporation. We're located all over the globe, but I work in Franklin, Pennsylvania. So right next door to where I grew up. It's about a 20-minute commute. If there's bad weather, it's about 25. So it's pretty great. The short commute's wonderful. And I'm a mechanical engineer here. I work mostly with design. And I think probably one of my favorite parts is just seeing stuff that we've designed come to fruition. We don't, since a lot of our, assembly floors are all over, the world, we can't exactly, and we don't really have a plant close by anymore to see our machines come together, but we do get a lot of pictures and videos, and that's really exciting to see everything that looks so small in a computer, become something, and it turns into this amazing machine, and it's huge. A lot of our, it's underground, I don't know if I mentioned this, but So this is an underground mining company, and our machines mine all kinds of minerals, including potash, which is used for fertilizer, salt. We have some miners in some salt mines, and the salt is used for, it's not table salt, but we just, that's used for, and during the winter time on the roads. And of course, coal for fuel.
Okay. I'll come back to you, but I'm going to move on to Elena. If you want to tell us a little bit about yourself.
Hi, my name's Elena Petrak. I actually was born as a military brat, so I spent a few years doing multiple things. Around 4 years old, we settled in Fairborn, Ohio, right outside the gates of Wright-Patterson Air Force Base. And I lived there until I graduated high school, and I joined the military, which is basically what my whole family did. And it was a good way to get money for college. So I actually, when I was in the military during basic training and tech school, changed what I wanted to do for college. I was actually going to be a Spanish teacher. And I ended up in a technical field in the military, and I got so excited about it that when I came back, I decided to start an engineering degree. Well, I had a really long path to getting my engineering degrees because I ended up marrying another military man and we were going to be transferred. So I settled for an associate's degree in electrical engineering technology so that I would have what I called a piece of paper before we started moving around the country. Well, when we got out of the military, we moved back to my husband's hometown, which is Finleyville, Pennsylvania, and I currently live in Baldwin. So I've been in the Pittsburgh area since then, and I was lucky enough to do quite a few jobs as a technician, but working as an engineer. Then eventually I did change roles many times, as most people do, and I got my bachelor's degree in engineering, and then I got my master's degree in engineering management from Robert Morris. So it took me 15 years from starting my associate's degree to getting my master's degree. But I was able to stay employed as an engineer that whole time and work in different industries throughout all that time. So currently I'm actually working multiple jobs, and that's kind of because of the pandemic. I'm able to work from home. So I'm actually kind of working 3 different jobs, 2 of which are training other engineers and technicians in some technical skills. And the third is a relatively new position that I just got, where I am now an electrical engineer for Astrobotic, which is going to put a lander on the moon at the end of this year. So I'm really excited about that because it's a whole new industry for me, and it's a whole new technology for most of the people around us. And so it's actually really exciting. So I do multiple things, and luckily I'm doing them all from my house at the moment.
Wow, that is just so exciting. You have so much going on right in your own home. So that is exciting. So tell us a little bit about your background. The students are just curious that they seem to think that you're in a spaceship.
This is actually I'm a big Whovian, so this is the TARDIS from Doctor Who, from Doctor Number 4's hunt. So that's what that is. But yeah, I mean, I have a very varied background. I actually started out as an assembler in companies, moved up to technician positions, moved up to engineering positions. I've worked in communications, medical devices, transportation, aerospace, military, obviously. So I've worked in a lot of different fields, and I've actually done a lot of different positions. I've been a test engineer, a quality engineer. I'm now in the design engineering and prototyping group. So this is at the very front end of stuff. I've always usually been what I call the back end with test and quality, but I'm finally in a company where I'm at the front end of everything that's going on.
Well, that's exciting for you. I'll be back to talk a little bit more with you, but I'm going to move on to Bethany right now. Bethany, if you want to tell us a little bit about yourself.
Hi, I'm Bethany Ford. I'm from Apollo, which is about 50 minutes outside of Pittsburgh, but I live in Ridgeway and work in Ridgeway now. I work for Allegheny Coatings. After high school, I knew what I wanted to do pretty much. My dad owns a construction company, so I thought I want to be a civil engineer because what contractor doesn't hate civil engineers? So I'm like, I'm going to be a civil engineer, and I am going to be the civil engineer the contractors don't hate. But once I got to Penn State, I discovered industrial manufacturing, and I just fell in love with it. So here I am in industrial manufacturing. I was lucky enough to graduate with my industrial manufacturing engineering degree and get a job in it. But it didn't start that way, but it went there pretty quick. I worked in environmental labs in college. So I didn't have a chemistry background, but they knew I was smart enough to do the job. So I did that job for a while, and I love that too, actually. So I'm very torn. I love the lab life, but they just couldn't keep me there. And so I started at Assured Testing Services in Ridgeway whenever I first graduated. And I love that job too. But Allegheny Coatings opened up an industrial engineering position, and it's our sister company. So these two companies are not the same company, but they're owned by the same people. So I found out about this job and applied, and I got it. And I've been here for 7+ years, and it's different every day, but I love it.
So what was your like aha moment when you switched like from your civil to your industrial? Do you have like an aha moment or?
Yeah, I don't really like civil engineering. I kind of did it just because I knew what it was. But whenever I found industrial engineering, it just enhanced my natural skill set. I love solving puzzles. Industrial engineering is kind of a mix between quality, production, and business all together. So it just kind of took everything that I was naturally good at and put it into a degree, and it was so perfect for me.
Well, that's great that you found your fit. So I'm just going to stay with you. How about if you tell us about like your current job? Like, what does your typical day look like?
It's different all the time, but I'm going to give you like for today. So typical day for me depends on what projects are going on. Right now, we are redoing our ERP system, our Enterprise Resource Planning System, which is basically the computer program that runs the whole company, the whole production floor. And I was so lucky enough to be a crucial part of this project. My company's kind of stuck in the Stone Ages, I like to say. So we're finally bringing some of our systems into the 21st century. And because it's all run by older men, and I am the youngest one, and I'm actually the only one here with an engineering degree. And I'm the only female too. We have female in management, but I'm the only one in the technical and production side. So because I know the quality side, the production side, and a little bit of the business side too, I got to help design the entire thing, and we're go live right now. So it's a lot of work. But I also keep track of our production, how we're doing, which processes need a little bit of tweaking, what problems we've had, and be able to get the right people to fix those problems if it's not me.
Well, that all sounds exciting.
It's
what
fun.
do you like the most about your job?
What do I like the most? I like finding the problems and fixing them. I mean, that's every engineer's dream, is to solve the problem. So.
Well, that's great. And what would be your biggest challenge that you face?
People, working with other people. So I prefer to work alone. I like being by myself, but whenever you have an entire team, it can't just be, oh, my ideas. There is no wrong answer. So it's hard to get other people to understand that your way is not necessarily the only way. So just getting the entire team to be on the same page, but that is such is life.
Yeah, very true, very true. Okay, I'm gonna move back to Elena and have you tell us about, what your typical day looks like. You've got a lot going on there, so I'm pretty sure it's a busy day.
Yeah, actually, depending on the day, I may be working for all three companies. I'm mostly working for two on a typical day. So one of the biggest things I'm working for with one of the training companies is it's a staffing agency, and they deal with engineers and technicians in all different fields across the country. Well, they used to go to all those different sites to train people, and obviously with COVID, they can't do that anymore. So one of my big jobs with them is I actually take some on-site training that they used to do, and I'm translating that to an on-demand computer courses. So I'm doing all kinds of voiceovers and taking PowerPoint presentations and turning them into, interesting presentations online so that they can now train these people virtually rather than having to go and sit in a classroom at all these different sites around the country. I also, with my job in aerospace, I'm constantly working with other engineers. So I have to work in a team all the time to help them review their schematics, look at their drawings. I'm actually looking at new components. One of the things we have to worry about in space is radiation. So I'm always looking at very tiny parts of the components to determine whether or not they'll be able to be used in space. And I will tell you, one of the big things we have is a lot of meetings. So I'm in meetings, actually, as soon as I get out of this, I actually have an all-day design review after we're done with this. So I will be sitting in a design review. Last night's took till 6 p.m. So those can be a little hard, but when you're not in the design reviews, you're actually doing designs. So that's always fun.
I think what's so awe-inspiring to me is, typically when you think space, you think NASA, you think Florida, and here we have, you're in Pennsylvania working on space. So that is just amazing. I find it truly amazing.
And the companies are actually privatizing a lot, SpaceX, Blue Origin, all these different companies. NASA might get out of the space business.
So what is like your biggest challenge in your job?
Well, again, not only because, see, I'm an electronic engineer, I deal with circuit boards. So I'm still dealing with circuit boards at the space company, but it's a whole new use for circuit boards. But with the training stuff, I'm dealing with a lot of industries that I don't necessarily know. I'm dealing with nuclear, I'm dealing with people that do windmills and oil and gas. So I'm learning a lot of new technologies all the time. And it's just really, it's like sometimes I get scared because I'm like, oh, how stupid am I? But I've got to understand that I was an electronic engineer. Now I'm trying to help an oil and gas engineer or help an aerospace engineer, which are different fields, but I'm learning a lot from it.
I think we can all relate with the technology struggles this past year has brought on for all of us. It has been a challenge for everyone for sure. Okay, I'm going to move on to Laura. So why don't you tell us about your, what your typical day looks like?
All right, well, my normal day is usually 7:30 to 4. I start my day off with just reviewing my daily tasks, and I try to prioritize everything, make sure I can get everything done for that day. I also wanted to go over an example of like my day to day. So right now we're running a test downstairs on the lower level of our building in the Product Development Test Center. We just call it the PDTC. And we are roof drilling because my sector of the company is roof drills. And so we are running that test right now. And my job is to troubleshoot any issues that arise, make sure everything goes smoothly, make sure that if we are missing a part, I order it. Or something breaks, I order more. And then usually there's a lot of meetings, a lot of reviews, a lot of project reviews. It's really important to make sure that you follow all the steps for a project. So, you come up with your idea, which for this bolter we have, and then go over, all the safety issues that might arise, and then making sure that the design itself is good, and then what issues could arise after the fact, and just making sure, that we dot all of our I's and cross all of our T's. So lots of meetings, lots of emails. Since we work globally with people, it kind of takes a little bit longer for communication. So it's really important for us to respond back to emails and stuff as soon as possible.
What do you think your biggest challenge is in your job?
I'd have to agree with Bethany. I think people, it's very difficult going, it's not difficult, but it's definitely a change of scenery going from, working with people in the classroom, because everybody's very much like-minded. We're all in the same age group, used to the same technologies. And so we work a little bit better in a different way. But moving to this career, I work with a lot of people who have been with the company for, is a man retiring this year who's been with the company for about over 45 years. And I know, he's wonderful. He has so much experience, so much wonderful information, and he knows an answer to everything. So it's fantastic. But sometimes working with him, there is a lot of barriers with understanding technology, understanding how he understands a way to do it versus how I understand a way to do it. So definitely working with people. And he is not the only example. There's a lot of different age groups. So kind of tackling that, a lot of different personalities. So understanding how to work with different personalities, that's the challenge. But also the software. I want to talk about that too, because software for us, at least, is changing all the time. We are merging from one type of software to the other, especially for communication. We were using, we were using Zoom in the beginning, but then we moved to Microsoft Teams, and now merging everything back and forth and stuff. We use Autodesk Inventor. It's kind of like SolidWorks. If anybody in the high schools, if you guys use that, it's very similar to that. That changes every year to every other year. And so we do get briefed quarterly about what changes there are coming, what we should expect, and make sure that we fully understand those, so that whenever it's implemented, that doesn't halt our progress on our projects.
Yeah, you do bring up some challenges that I think a lot of us face with working with people and different personalities and in different age groups anymore. You're right, that is a definite challenge. So I see we have like a lot of questions coming in, so I want to make sure we have time for those. Lauren, do you want to review those and see?
Yeah, Elena kind of jumped in the chat and answered a few of them. She's located in the Pittsburgh area. But Elena, I was wondering if you could maybe elaborate more on the Space Force. I know I'm personally not familiar with that. I don't know if anyone on the call is. So maybe if you could give some more information on what that is and how they could go into the military and use that to get into the space field.
Okay, I'm not a whole lot familiar. I do know, being from Wright-Patterson Air Force Base, my family was involved. They were actually being considered for the location, but I guess they ended up in Alabama instead. But the Space Force is basically an offshoot of the Air Force, and they're going to be dealing with all of the things in space, not necessarily defense, because we all think of, for us older people, Star Wars in the 80s. But a lot of these communication satellites and low Earth orbit satellites that are up there have to start being kind of coordinated and dealt with. So they're going to be dealing a lot with things that rotate around the Earth, and also just like, a high altitude spacecraft, that the kind, if you've ever seen on a video where someone goes up in a plane, but they're at zero gravity in the plane. So they'll be dealing a lot with that. And in the future, more of the missions that would be military based, going to the moon, to Mars, to any place like that. So it's really, right now, I think you still go through basic training as if you're in the Air Force, and then you get transferred into the Space Force. I actually know a few people that have, as officers, have been transferred into the Space Force, but I'm still a little light on it myself, just because it is such a new thing. They just celebrated their 1-year anniversary, so they're really new, but I do know that the Air Force is how you get to the Space Force.
Great, thanks, Elena. And we do have another question here. Okay, so what classes or clubs would you recommend for students to participate in during high school that would help them better understand and if engineering is the career for them? And actually, Amy does have a section at the end of our program where we're going to give you some tips on that. So Amy, I don't know if you want to elaborate now, or if we want to hold that one until the end, maybe.
Yeah, I'm not even sure if I addressed clubs in that. So I don't know if any of, our guest panels have any suggestions for the students that they can Okay, go ahead, Laura.
Yeah, for classes and clubs and stuff, I definitely suggest anything STEM related, as high a level of math as possible. If you're able to get into calculus, that's great, go for it. Try out as many science classes as possible because that's the way that you're going to figure out what you want to do. I remember taking chemistry in high school, and I took Chem 1 and 2, and I realized that I really wasn't a huge fan of chemistry, so I knew I didn't want to go into chemical engineering. And the same thing for the clubs, you kind of get a feel as to what it would be like to work with those types of things, whether it's, robotics or, chemicals or whatever. You kind of get a feel as to what interests you and what does not.
I will say I am a state judge for PATSA. So if your school is a member and does PATSA, find whatever it is you're interested in and join whatever events you can, because that's going to help you identify what your passions are. So to me, PATSA is a very important club group if your school is participating in that, which is the Pennsylvania Technology Students Association. And it's actually an international organization. So if you keep winning, you might actually go to the international competitions at the very top.
Hey, can I add something too for anyone who has a school that has the robotics competitions? Robotics is another area, and that's become very popular in the last few years in particular. And there's a lot of our rural schools that are involved in that. So, if you're interested in mechanical engineer, how things work, how to put them together, and it's fun. So robotics competitions or robobots is another one.
Those are all great suggestions. Thank you so much. Lauren, do we have any other student questions?
It looks like we're caught up on questions, but Kara wanted to add that physics classes are super important too.
Okay, great. Okay, so I'm gonna go on, let's see, we will go back to Bethany and ask a couple more questions. So what did you do in high school to help you prepare for this career, and what advice do you have for someone who wishes to prepare for this occupation?
So in high school, my high school wasn't very good. We had the option, we didn't have the option to have more than, 4 electives. So I was in the band, so that filled up all of my electives. So I kind of struggled. I didn't really get the opportunity to take as many shop classes as I would have liked. But I did take, because you're required, shop class, and I actually, whenever we did drafting, I got bored right away. So my teacher started giving me harder and harder and harder things. You flip to the back of the book. Okay, can you draft this one? Can you draft that one? So I got extra work. Yeah, but I loved it, and it was so much fun. So I knew that I liked that. But for me, I worked construction for my dad's company through high school and also through college and on the weekends. So that's how I knew that I liked to work hands-on, because I was working hands-on. I learned how to run equipment, power tools, very important. I didn't get shop time because I was out in the field, so I didn't get shop time as much. But now I love it. It's so much fun. My suggestion would just be figure out what classes will put you in a shop, because that's hands-on is so important, in my opinion, and in my line of work. If you can go into the shop and help the guys, they will take you very seriously.
Okay, that's great advice. Great advice. And I'll just stay with you for one last question for you. How can someone entering this career or industry stand out from the crowd?
That's how you stand out, hands-on. So what I did, I was lucky enough to do this. Whenever I first started working here, I needed to profile. We have big ovens, and you need to know what temperature your parts are going through these ovens. So I get to test the parts and see what temperatures they make going through these ovens. And we didn't have a a vault to protect my plastic data logger going through a very hot oven because plastic melts at 170-ish and our ovens are 700 degrees. So I needed to figure out how I'm going to send this thing through the oven without ruining it and get successful data. So I actually went down into the shop and hey guys, does anybody have a weld hood that I can borrow? That's how they take you seriously.
That's great advice. Great advice. Yes. Thank you so much. So we'll move to Elena. How about you? You know, what did you do in high school to help prepare you? And what advice would you have for someone that would be preparing for this?
Well, I guess I was lucky, probably because of where I live, you know, next to an Air Force base. We had a lot of students and a lot of good curriculum that was very technical based. So even though I was thinking about being a Spanish teacher, I was in calculus classes, I was in physics classes, and all that other kinds of stuff. So I had a good, just basic high school career. But one thing I will tell you that most people don't think about when they're going to be an engineer, you need to take writing classes and speech classes. You will be surprised how much of your engineering career is taken up with writing reports and giving presentations to other engineers and management. So you can be as technical as you want, but sometimes those really introverted people can't express the really important thing that they figured out. And that's what you need to do, is to make sure that you're well-rounded in understanding that you can't just figure it out. You have to tell other people what you figured out. So, and to be successful when you get into the field, my biggest thing is show your passion. I am not an expert in any little thing. I didn't know anything about space before I joined this company, but I showed my passion and an interest to learn, and that's what they hired me for. Yes, having an engineering degree helped, but they didn't just say, I need an aerospace engineer. They saw that I was an engineer who was really interested in learning about aerospace. So they hired me in, and they're teaching me the technicals, but I'm also teaching them a lot about the general stuff I know. So you show your passion on what you like. And a lot of times if they can pick up on that little thing, they'll hire you in just because they need that extra little piece of your passion.
Thanks, Elena. That is great. Great advice. You know, I'm a full believer of lifelong learning. You know, learning doesn't stop at high school graduation. It continues on in life, and that's definitely a good point to make out. Okay, then we'll go to Laura. How about your answers to the questions? You know, what did you do in high school to prepare, and what advice do you have?
Yeah, I guess kind of reiterating from our conversation about the last question, taking those classes, just kind of taking a leap of faith into where your interests lie, jumping into those classes, jumping into those clubs, especially with the clubs. You're not going to lose anything, you know, from jumping into a club. You might find out that it's the best thing to happen to you, and that you love electronics and you want to pursue that. I think something else that's really important in high school is kind of figuring out where you want to maybe do internships. If you know for a fact that you want, in high school, I knew that I wanted to do mechanical engineering. I was so set, and in my opinion, it's pretty versatile and you can do a lot of stuff with it. And I just knew that that's where I wanted to end up. So I did research about different companies where I thought maybe I would want to do internships, and started looking at things that the company did and did a lot of research on, you know, their mission and stuff. And so whenever I got to that point, our professors told us not to start into internships until after your junior year of college. But I applied for an internship with Komatsu after my freshman year, got it, and then continued on with the company for 4 summers and 1 winter. So after I graduated my undergrad and with my master's degree, I had 4 summer internships and a winter internship under my belt, with a lot of commitment to the same company for those 4 years. So definitely doing research on companies that you're even interested in. because then you can kind of see where careers go, what people do, what, your expectations are, because you can easily just go on and see what, the job specifications are. And I guess to stand out in the crowd, I would say that experience, I agree with everybody else, and that experience is key. You can do a lot of things in college. From my experience at WVU, they have this program called the Eco Car, and you can work on, I believe General Motors donates a vehicle, and they tasked 12 different universities across the United States with making it into a fuel efficient hybrid vehicle. And so that would really look great on a resume, if you apply to Ford or Tesla, starting into that job already and figuring out, especially junior year and senior year of college, and even sophomore and freshman year, trying to figure out, maybe where you want to work. I think that's, that's really important. So if maybe at least what area you want to work in, then it'd be important to get the experience that would make you stand out, from a lot of other people, because there's a ton of people with engineering degrees, but not a lot of people that did the Eco Car project. And so, somebody with just a basic degree, applying to Tesla would look a part of the crowd, but somebody with that background who's worked with vehicles, who has a ton of experience, who's, worked on vehicles, I believe it's a 3 or 4 year project. And, so having that much experience, that would look fantastic on a resume.
That's all great advice. So we have about another minute for this session. Do you have any last minute words, maybe something we didn't get to that you wanted to say?
I just want to say that I've always, whenever I've talked to young people, I've said, what is your favorite hobby to do? No matter what your favorite hobby to do is, you can figure out what engineering degree you can go for that will help you keep your passion of your hobby. So I don't care if you say you're a dancer, there's an engineering degree, there's the physics of dance and all that other stuff. If you want to be an engineer and you love to do something that you think is totally unrelated to engineering, there is an engineering field for that. So it will help you keep your passion, so that going to work is not going to work, it's just having fun.
That is great advice. Bethany, did you have anything?
One too. So I'll make it quick. There's a lot of smart people out there. Smarts is not it. Somebody who works hard will always win out over somebody who's just smart.
That's great too. Laura, did you have anything last minute you wanted to say?
Yeah, I just wanted to reference that first question about, what usually is the job length for an engineer. And I really think that depends on you as a person. You're going to need to make sure that you do challenge yourself. And if you get to a certain point in your career, if you're with a company for 10 years and you just don't feel like you can progress anymore, don't be afraid to go to a different company and challenge yourself. It's all about your job gratification. So if you're not feeling, like you are being the best and you have room for growth, then definitely don't be afraid to go out there. And Amy, like you said, the continuing learning, don't be afraid to take on seminars and trainings and stuff to help you grow as a person, because that's really going to help you professionally.
Yep, that's great advice. So I just want to thank the three of you again for participating. You have great information that the students could learn so much from, and you all have amazing jobs. They sound so exciting, and so thank you so much. Okay. So we are going to move on now. We'll get back settled in and we'll move on to our round 3 of bingo. So we have a geomatics. Oh, and I know that, we already had some bingo winners, but I would like to just continue on because the slides do give you, there are so many different areas of engineering, and the slides really do give you a feel for your all your choices. I know I was surprised at how many was included in this on these bingo slides. So I know I learned as I was putting it together. So we have Geomatics Engineer uses advanced equipment and techniques to make precise measurements used to map the Earth and monitor its changes in the environment. We have Systems Engineer, develops systems for workplace efficiency, risk management, measurement, and refinement. A Cyber Engineer designs and monitors computer cybersecurity systems and software to keep people safe online and prevent hackers. And we all know how scary that can be, so we do appreciate those cyber engineers helping keep us safe every day. A geological engineer combines engineering and research skills to assist in mining and construction projects, such as assessing ground conditions and other natural hazards before starting construction. A tip is if you were a child who often picked up special rocks, tunneled in snowbanks, built forced footbridges or sandcastles, you were literally toying with geological engineering and you probably didn't know it. An aerospace engineer designs and tests aircraft, satellites, and missiles. And a tip is that although aerospace engineering is an exciting career field, those wishing to enter the industry can expect strong competition for positions. An architectural engineer works in the planning and design phase of building projects in conjunction with civil and structural engineers, focusing on designing the building itself and the interior design. Okay, so that ends our round 3. All right, so at this time, we're going to move on to our education panel. And our panel is going to just share with you some of the educational programs related to engineering. And we're going to start with Lauren Zickafoos from the Northern PA Regional College, and she's going to talk about the Applied Technology program. Welcome, Lauren.
Thanks. Hi, everyone. So my name's Lauren Zickafoos, as Amy mentioned, and I'm actually talking about this program from the advisor perspective. Our next 2 speakers, Kara and Selma, actually went through the programs they're discussing, so they'll be able to have some more helpful information from a student perspective. But I did think it was important to share this program because it can be used as a stepping stone. I know we've talked a lot about various programs and degrees and education that you can go on and earn. And for the Northern Pennsylvania Regional College, we offer associate degrees, and associate degrees are a great way, to earn an education at an affordable cost. We currently serve 9 different counties throughout Northwestern Pennsylvania, and those include Erie, Cameron, Crawford, Venango, Warren, Forest, McKean, Potter, and Elk counties. So you can take this degree in any of those locations. And the Applied Technology degree, it really focuses on industrial maintenance. So you're learning about all different types of processes that you would see in various manufacturing settings, specifically throughout Northwestern Pennsylvania. So these include electrical, robotics, automation, different hydraulic processes, and there is a lot of lab and hands-on work, which is great. You know, if you're someone that's really just not sure which niche you'd like to go with. I know we've had a lot of specific programs we've talked about today, but some of you might just want a more general program that could introduce you to different areas. And then of course, if you did happen to find what you were interested in, you could always go on and earn your bachelor's and specialize at another 4-year college. So that's really all I wanted to share today. And I'd really like to allow Kara and Selma to give some more detail on the programs they've gone through. So Kara, the floor is yours.
Thank you. Hi, everyone. Like you said, my name's Kara. I'm a non-traditional civil engineering student at Slippery Rock University, meaning I went into the construction field for a while and tried to work. And after realizing I was hitting so many roadblocks, I decided to go back to school. Let me tell you, getting a degree or any type of college education or trade school diploma will absolutely open doors. I mean, I personally believe with experience that you will regret not continuing your education and continue learning. It's not near as much fun once you have all those other adult responsibilities. With that being said, I want to begin with kind of like a broad overview of what you would get with a civil engineering degree. When I told people I was going to school for civil, most people usual response was something like, oh, you want to work for like PennDOT, just build roads and stuff. And yes, civil engineers are highly employed to design roads and bridges and work in heavy construction, but that's only a small portion of what a degree in civil engineering can really do for you. I mean, you will gain the fundamental knowledge at Slippery Rock, at least, to get into so many different branches of the civil engineering field. You will learn structural, which can be bridges or designing the bones and muscles of commercial buildings, or giant skyscrapers, or maybe you like environmental or geotechnical if you have an interest in chemistry or biology or geology or green materials or saving the ecosystem, if that's really something we should all be concerned about right now. Or maybe you like water resources if you're interested in hydraulics or fluid motions or the inner workings of dams. I mean, these are just a few examples of what you could be a part of if you had a civil engineering degree. So it's not just the hard hat wearing crew that you see along the interstate when you go through road construction. At Slippery Rock, they now offer 4 degrees, civil, mechanical, petroleum and natural gas, and industrial systems. I did some digging last week and I found out that of the total of 144 students that are enrolled in these 4 programs, there's only 19 women, which I was like, really, 19, that's it? And they're like, yeah, that's it. But anyway, civil engineering at Slippery Rock is relatively new. So new, in fact, that the first group of civil engineers won't graduate until the spring of 2023. So it's been exciting being part of this program, as they brought in professors from all over the world. And it's pretty mind-opening getting to learn from these people and get to know from these people from different ethnic backgrounds that know so much about the field that you're wanting to go into. I do think no matter the university that you go to, the degree that you pursue, you will meet so many amazing people from all over the place. One thing I love about my engineering classes is all the hands-on that you get to do. Like they said in some of the other, that right now it's kind of virtual, which is not as much fun, but the professors know that you learn by doing it, that you learn by applying it. And so they find simulations or create projects that instill information long-term, not just, to pass the test. At Slippery Rock, we have a physics and engineering club, which brings together the entire STEM departments. So you get to hang out and meet people that all have a similar interest and to get involved with things in the community, or to talk with people that, that like the same things that you like to do. We have an American Society of Civil Engineers group, which is pretty cool because they bring in people that work in the industry, and you get to listen to them talk about the places that they work, or like the things that they do on a daily basis, kind of like what we heard today from people. And it kind of opens networks and job opportunities so that you're able to see the people locally and what they did with the same degree that you have. A couple of weeks ago, we held our very first Society of Women Engineers chapters meeting. It didn't have the best head turnout, but hopefully once everybody's back on campus and we can actually really socialize, we'll be able to bring some more people and reach out more and become an official club on campus. So that'll be cool, because we'll be able to go out into the community with specifically women engineers from all different universities, and be able to be a part of all these big things that are happening right now. I mean, as you heard a lot of people say, that I'm a huge introvert. I mean, I steer clear of groups. I am honestly terrified of public speaking. So, but pursuing this degree in engineers has given me something to be passionate about, and has opened up job and internship opportunities and leadership opportunities. And it has really helped me convince myself that I have the confidence and the courage to stand in my discomfort and be able to pursue something that I love and pursue a job and a career that I know that I will enjoy every day. And I think anybody can do that. Thank you.
Thanks, Kara. That was wonderful. Thanks for sharing that. All right, Selma, we're going to pass the floor over to you.
Hi, everybody. I'm Selma. I'm originally from Bradford. So I graduated from Bradford High School in 2014, which seems like a lifetime ago. And I went to the University of Pittsburgh, located here in Pittsburgh. And I went in, so my path to engineering wasn't quite traditional as well. So I came in and I said, hey, I love science. You know, I don't really know what I want to do, but I know that I love science. So my undergrad I finished. I did an undergrad degree in biology. And so I graduated and I'm like, all right, what's next? What do I do? And so I didn't really have a direction. So I saw Pitt had a really cool bioengineering program. I was like, I don't know if I'm into engineering, but let's give it a go. Let's see what it's about. And so I did my master's in bioengineering. And while it wasn't the most traditional path, I can tell you it was one of the best programs. You know, Pitt has an exceptional engineering program, and I'm like diehard Pitt fan here, but I have to say, if you're considering, you know, doing any field in engineering, you know, Pitt is a really cool place. So it is a city, you know, that was a big thing that I, you know, looked at when I was looking at programs. I was like, you know, I grew up in a small town. I kind of want to change. So I chose Pittsburgh because it is a city. It's not too big. So when you're on campus, it feels like, you know, it's very expansive. However, it is not, you know, too large where you get lost. And the engineering program there is fantastic because they have a lot of different programs. So your first year as an undergrad, you take a lot of the basic classes. So you'll take Chem 1, Chem 2, physics, calculus. You have to take some coding classes. Yeah, and then you get to choose some electives. And then once you get into your second year, you're able to choose a track and then specifically choose electives based on that track. And I think that the really cool thing about Pitt is, you know, it's a really up and coming city. There's a lot of startups. There's a lot of great companies around here, a lot of amazing engineering opportunities. And the great thing that the University of Pittsburgh, you know, has is the co-op and internship program. I know a couple of people have touched upon this, but this is really a big thing. So this is kind of how you decide, you know, you might have an interest in something, but this is what really helps you decide what field of engineering and, you know, what position within engineering is the best fit for you. So that's something that, you know, when people are saying, okay, like, you know, you'll figure out what kind of engineer you are and what kind of engineer you want to be. I think the greatest way to understand where you fit in the big picture of everything that engineering can offer you is through these co-ops and internships. So we have, so Pitt has an agreement with, I want to say that it's a huge list of companies, maybe like 40 to 50 companies around the Pittsburgh area. And the co-op program is like a rotational program. So you know, I think 80% of the undergraduate engineering students will take advantage of this, no matter what track you're in. There's different companies that might be more suited for you. And you will do, after your first year that you complete, you'll do a semester of class. So your electives, and then of course, all your, you know, classes are for your program track. And then the next semester you will work full-time. So sometimes that's paid, sometimes that's unpaid, sometimes it's an internship rather than a co-op. Usually you'll do 3 rotations. So then you'll work full time and you'll report to this company, and you'll get to really learn what it's like to be an industrial engineer, a bioengineer, you know, a mechanical engineer within these companies. And I think that the really cool thing that this teaches you is not only the opportunities that you have with an engineering degree to be an engineer, excuse me, but also the other positions. So I think a really cool thing that you learn is that if you have other skills that you're interested in outside of engineering. So for me, that's personally management. I thought I'm a good people person. I love, leading projects. I love seeing them start to finish. And so you get to experience what is it like to be a project manager, a product manager, or maybe just somebody from the engineering team. So, if you're somebody that's an introvert and you don't really love to do presentations, maybe you want to be part of the engineering team. But through these co-ops and internships, you get to work with so many people. You get to see what the diverse team looks like. And you can say, okay, you know what? I have some strengths. I'm good at presenting. I'm a good people person. I like to, do new product development. So let me look into this. And being an engineer and really learning a vast amount of skills really will help you in progressing forward in your career. So I think that's a really cool thing about Pitt. Also, we do a lot of study abroad programs as well. So if you are like me, a bioengineer, biomedical engineer, as an undergrad and a graduate student, you also have the ability to study abroad in things that you can do like a quick week, 2 weeks, or you can do a whole semester. And it can be in something totally different. So we have some really cool, sustainability. I think sustainability in Belgium. We have, or maybe that's Denmark and Sweden. Anyway, there's a whole list of them on the website if you want to look. But we also have, engineering for social change in Africa. And then we have, engineering a craft brewery in Belgium. And so you have all these options to explore different things. And you don't have to, I think the big thing that I learned going through this program is you don't have to be sure of what you want to do. You have the opportunities, and Pitt really sets you up to explore different options. So you can get through your first year and be like, I want to be a bioengineer. And you take that first tissue engineering class and you're like, absolutely not. This is not for me. You have the option to change, and you can go to something that you're more interested in. And that's totally okay. So Pitt does different tracks, and you can also take more than 4 years. So big thing with our co-op, it's a 4.5-year program if you do 3 semesters worth of the co-ops, which I can't remember if I mentioned this, but it's really, those things are really like important. Like 80% of our students will take advantage of that, because usually if you make a good impression there, you show that you're passionate about the work, this is a field I want to work in. Most of those employers will offer you a full-time job after graduation. So they do a good job of setting you up. So after those 4.5 years, sometimes people even take 5 years. That's very common. If you're already taking 4.5, people think, why don't I just pick up a minor? And you can pick up a minor in something completely different. A lot of people will do economics, entrepreneurship, that kind of stuff. And then you graduate in 5 years. And then with your co-op, you're usually set to have a position. I know COVID kind of messed that up these past year for some students, but still Pitt does a really good job of helping you out. More specifically, I would say on the bioengineering side. So that's something that, my perspective is a little different because I moved into bioengineering as a graduate student, but most of my classes, if not all of them, also allowed undergraduate students as well. So that's something really cool. Like if you have an interest and something's listed as a graduate level course, you're still able to take that as an undergrad, and you still do these cross-functional teams. So a lot of my teams were from, of course, my bioengineering master's program, but also we had some MBA business students that wanted to join. They wanted to see what it's like to do, new product development, manufacturing, prototyping. We had electronics courses. So it was really cool. You get like a cross-functional group that you get to work with, and everybody brings their strengths to the table. So when you have to develop a business plan, you reach out to that business person in your group and you're like, okay, what can I learn from you? And so it kind of works that way. And Pitt does a really great job of structuring the classes that way so that everybody in different fields is able to participate, to bring value to the course, and also learn a lot from the course as well. I think the big thing I want to mention, though, is Pitt is really great for the biomedical program. I personally had a wonderful experience there because UPMC is right on our campus. So a really cool thing is that not only are you sitting in the classroom and learning about what it's like, what does it take to be a biomedical engineer, a bioengineer, you get to help out in new product development with the physicians and nurses at UPMC. So a lot of our classes were, okay, you have an interest in, say, cardiothoracics. You want to help somebody that has some sort of problem with their heart. So there's electives you can take for that. And then while you're doing your core classes, they allow you to go into the hospital. You have a clinical mentor, so a heart surgeon, and they say, all right, you can watch the surgery, see where you think there's an unmet need, and fix it. And so you go in there and you're observing these surgeries and you see, okay, there's a problem here. I think we can fix it with this idea. And so you get to work with a doctor, you get to work with your team, and you get to see this project all the way up until, you prototype it. And sometimes it works, sometimes it's awesome, and sometimes it doesn't. And then it teaches you to pivot. It's not, things aren't always going to go as you plan. So it teaches you to change direction, and maybe this one won't work, but the next one will. And if it does work, I have to say Pitt does a really great job of something that's really cool when you are in these new product development types of programs. They really help you with IP. So if you develop a really cool idea and you say, okay, I think that this is a really good idea for a startup company, Pitt will actually give you the resources and IP lawyer to file your own patent. We do a lot of entrepreneurial stuff. So we do the big idea competition every single year. We're first prize just for your idea. It's kind of like a pitch competition, I would say. Just for your idea, you can win up to $10,000. So they really promote entrepreneurship. They really promote, bringing new skills to the table and teaching you all sorts of different aspects. So as a bioengineer, of course I did, tissue engineering. I did everything that has to do with biology, that kind of stuff. But I also learned electronics. I found an interest in that. So I took some of those courses and I was able to learn something, 3D printing, manufacturing, all sorts of different things. And it just is a wonderful environment and a wonderful opportunity for you to not only be within a great program, but a great community, and really a community that fosters, new learning and continuous learning. And that's something that, I think is a wonderful experience. If you have any questions about Pitt, of course, feel free to send me an email. I have to say that really the co-op and the internship program is really what sold me. That's actually how I got my full-time position after I graduated. I did an internship, and, if you really show them that you're a hard worker, that you care about what you're doing, it'll set you up for so much success. So I see I got a few questions there. I don't know if anybody answered, but that's my spiel there. If anybody has any questions, let me know. Happy to answer. Thanks, Lauren.
Thanks, Selma. One question on here. I just was wondering, do you know of any scholarships specifically that bioengineering might have? We had a student on here that is interested but concerned about the affordability.
I would absolutely reach out to advising and talk to them. I know I'm not quite sure about the undergrad, but for grad school, they will offer you like significant scholarships. If you're a full-time student, academically based, I think a lot of the time, they will offer you scholarships. If that's something you're considering, I know that my program offered full-time and part-time, and for the students that chose part-time because, it would be easier for them to pay for the college, the advisor for the program actually worked with them to get them enough scholarships to do the full time. So it's definitely out there. I know it's a little tougher in undergrad. You're coming in with a big undergrad class, but never, don't hesitate to ask them because people will help you.
Thank you.
Mm-hmm.
Great. It looks like there's one more question on here. Did you ever have to decide between biomedical or biomechanical engineering? And how did you make your decision if you did?
So that's definitely a tough choice. I think our program was heavily skewed towards biomedical. So it's more so focused on the ideation, so new product development. So you, like I said, you go into these environments and you say, okay, this is where the unmet need is, what is the solution? How can I develop it? And I personally didn't have the mechanical engineering skills. A couple of my colleagues did. They had mechanical engineering backgrounds. So they kind of took the reins on that, where I took the reins on other things that I had strengths in. But that is an option. You can do, biomechanical. We do a lot of robotics. A lot of my colleagues did internships with wheelchairs, with artificial limbs, that kind of stuff. So that option is there for you if you're interested. So you can definitely go down that path as well.
Great. Thanks, Selma.
Yep.
All right, Amy, I think back to you now.
All right, thank you. Yes, thank you, panelists, great information about the schooling. And there are so many options out there. So thank you so much. Okay, so we have just a little bit of time left, and I'm going to do a brief overview of, like, you know, is engineering a fit for you? So we're going to take a look at that real quickly and see how that fits for you. So who makes a good engineer? There's no one type of person who becomes an engineer. And as Bethany had said, it's not all about smarts, math and science. You know, are you creative and imaginative? Do you like collaborating with others? Are you curious and persistent? Do you want to make a difference? You know, if these sound like you and you want to dig a little deeper to find your fit in engineering, then you want to ask yourself the following questions. So what kind of impact do you want to have on the world? As Sandy had said, every day brings new problems to solve. So what problems do you see out there that you would want to solve? There are so many of them. And Elena had said about showing your passion. So what are you passionate about? Your passion can lead you to what type of engineering it is that you are interested in. If you are interested in making a difference in the world, then engineering is a great choice, as it gives you the skills and expertise to impact thousands of lives every day. So think about, how do you want to make a difference in the world? And then what kind of things do you like to do? So as you see here, you know, what kind of things do you like to do? Work on a big project, design, organize, travel, all these kind of keywords. If those sound like you, these are actually hallmarks of how engineers do their work. And then, is there an area you are interested in? So as Elena had said, look at your hobbies. You know, what are you interested in? What are you doing now that could lead you to an area of engineering that would be a good fit for you? And like she said, fashion, if you're into fashion, if you're into medicine, there are all kinds of opportunities out there waiting for you. And while it's important that engineers have a solid background in math and science, just remember that the best engineers are people who use their communication skills, their imagination, their creativity, their analytical abilities to invent, design, and create things that matter to make the world a better place. So we have a Google site that has a lot of resources on it where you can explore types of engineering. You can find engineering degree programs, and you can even take a fun survey to find your fit. But keep in mind, these surveys are just for fun. They're going to show you look at your interests, your personalities, and it's just a fun way to see what you connect to. So, you know, hopefully you'll take some time to look through those. Also on the site is a link to chats with changemakers. And these are live and recorded interviews with engineers and technicians who are working hard to make the world a better place. So they're adding new ones all the time, and they have a bunch of recorded sessions. So if that's something that you're interested in, be sure to check those out. And I'm going to be sending out a post email, and I'll have the link to that Google site. And on that site, some of you have been asking about recordings. We will have the recordings of the session also for you. So there's lots of good information on that Google site, and we hope you'll take some time to look that over. And then we'll be including a post survey in the email that goes out. And if you complete that by March 3rd, you'll be entered for a chance to win a $25 Amazon gift card. And also the first four bingo winners will also be getting a $25 Amazon gift card, and you'll receive those through your email. So I just want to thank you to our sponsor, the Western PA Women in Manufacturing. I will put a link to them on that Google site so that if you're interested, you can click on that and learn more about them and ask them some questions. And I want to thank our education partners, because without them, we wouldn't have had the success of having so many people attend our program today. All right. So with that, that's going to complete our program for today. Time flew by. We could talk about engineering all day, I think. There's so many topics about it. So hopefully we can continue this as a, as a yearly event so that we can learn more about engineering every year. Lauren, do you have any last minute words you want to say?
I just wanted to thank everyone for taking the time to come out today, and I really hope that the students all benefited. I know just being a colleague and coworker for a lot of you, it was really great to hear what you do on a daily basis, and thank you so much for your time.